Hello everyone, this is Professor Robert Solis and welcome to this next video lesson. Today we're going to be talking about creating the blackout game, but we're going to use a two-dimensional array to store these buttons. And the reason why we're going to do that is because the problem last time we worked on this game, we had to click every single button, double-click every single button, and then generate the code for that button. So for example, if the user clicked this button, then we would say that we would have to call the swap function for this button, and this button. So in other words, btn1, 2, 3, 4, and that's it, right? And also btn0. And that was not a very good idea because then we had to generate basically 9 chunks of code for these 9 buttons, and maybe there's a more elegant way to solve this problem. So everything else is pretty much the same as the previous time that we had to solve this problem, but what we're going to do is use two-dimensional arrays. Alright, so what I've done is I've generated this little PowerPoint presentation that kind of helps us understand how we're going to go about doing this. We got 11 slides. Let me go ahead and start the slideshow here and show you how we're going to be creating the breakout game with a two-dimensional array. Well, this is the initial game setup, as you can see, obviously, right? So we have randomize. When we first started off, we randomize some of the buttons so that they're white and other buttons so that they're red. Alright, now in this case, when the center button is clicked, let me go back over here so you see this is the initial setup, but if I were to click the center button, then obviously the adjacent buttons are going to be swapped in terms of their color. So notice over here these are white because previously these were red, and then these are white right now, but then if I click the center button, they're red because all adjacent buttons of the one that you clicked must be swapped. So, whoops, let me go back over the next one. Here we go. So here's the thing to consider. Every time I click the center button, the one to the north, south, west, and east gets swapped, in addition to the one that you also clicked as well. Wouldn't that be nice if I just had a function that when I click a button, I would say swap the color of the one that you clicked plus the button to the north, south, west, and east. Every time. That's what it does. It just swaps 5 buttons. North, south, east, and west. And the one that you clicked. Here's the problem. If I click this corner button, there's a north, there's an east button, but there's no such thing as a west or a south button. So maybe that idea doesn't work. Well, it doesn't work if you have 3 buttons, but it would work if I had a 5x5, say for example. Alright, so let's consider this. The first thing I'm going to do is I'm going to create a two-dimensional array. And so here are the indices that you see down here and over here for the two-dimensional array, which is nothing more than a table. Alright, now having said that, what I'll do is I'll take those physical buttons that I created, those 9 buttons that I created on the Visual Basic form, and then I'll place them in the middle, as you can see here, of our two-dimensional array. So these outside array items or array elements, they don't have anything yet. I mean, they're supposed to store buttons because that's what this array does. It stores a bunch of buttons. But right now they're null. They don't hold any buttons right now. All that we have done is assigned these 9 buttons to the center of the two-dimensional array, and this is how we're going to do it. So in this case, if I label this button over here btn11, and the reason why I call it 1_1 is because that one represents this row and this second one over here represents this column. So btn11, which is this button in here, put that in games button, which is the name of this entire array, put that in games button 1, 1. Well, where is 1, 1? 1, is right here. The intersection is right here. So I'm strategically placing this button and I'm strategically naming this 1, 1 because I want to put it in 1, 1. And I do the same thing for the remainder of the other buttons. This last one is btn33. That's this guy over here. I place that into games button array 3, 3, which this is 3, this is 3. The intersection of those two goes right here. So this is how I assign the buttons into my two-dimensional array. Now, with the other perimeter buttons, what I'm going to do is I'm just going to place a new button in each of those. I don't care what those things are called. These guys, I don't give them a BTN whatever name. I just just put a button in them, right? So let me go to the previous slide here. No, there's no, this is supposed to hold buttons, but they're holding null right now. There aren't any buttons inside here. Now there are. As a result of these statements, these array elements have now been populated with buttons. Well, now that solves my problem of if the user clicks this button, remember we said we want to have a function that swaps north, south, east, and west? Well, now we could swap the north, the south, the east, and the west. And of course the one that we clicked. It's just that when the user clicks this button, we're only going to see 3 buttons change, but in memory, these 2 will also change. Now that's fantastic, because then we have a way of calling one function that swaps 5 buttons all the time, regardless of which one was clicked. It just happens to be that these 2 are phantom buttons, and that they swap, but we don't see them. They just swap in memory. Alright, so let's take a look at this. In this case, the user clicks the center button, right? So let's ignore the other ones. I can see that I grayed them out or darkened them a little bit. So if the user clicks that, here's what we're going to do. This button right here, this is 2, btn2_2. Well, since they clicked this button, anytime that you click a button, it goes to a handler. And I'm going to show you the code for the handler in just a moment. But just take my word for the moment that when you call that handler, there is a sender that is part of that handler, and one of the components or properties of that is name. So sender.name is the name of the button or the item that was sent to this handler. In this case, since we're clicking a button, it's going to send the name of this thing. Well, what is the name of this thing? btn2_2. So btn2_2 is now being placed into a string. A temporary string that I instantiated, or that I created rather. Just something like, dim temp string as string. Alright, well now that this is, quote, btn2_2, I need to get that first 2. Well, where is that first 2? Let's see here. In this string, it's 0, 1, 2, 3. It's located in the 3 position, and I just want this 1, 2 by itself. That gives me the row. Well, if I use tempString.substring, it says move to the 3rd position. Okay, 0, 1, 2, 3. There's the 3rd position, and I only want 1 character. Okay, so that means just this 1 character in length. So give me the 3rd position, 1 in length. That would be this number 2. So the row is now 2. Well, how do I get that second 2? Well, let's see. Where is it located? 0, 1, 2, 3, 4, 5. This is located in the 5th position of this string. So that's why I say temp string substring 5. And again, I only want 1 character, just that 1 in length. So there's the 1. So what this statement does is it extracts this 2. So now the column has been set equal to 2. So if row is 2 and column is 2, now I know that the button that has been selected is this one right here, which is row 2, column 2. So this is the appropriate button. Now, what I'm going to do is I'm going to call a function called swapGame. And what that's going to do is it's going to call a function, or rather it's going to call the function swap, rather, and it's going to send it an array element. Now, what array element should I send? Well, notice that I send game buttons, row, comma, column. Well, that's this guy right here. Row is 2. Column is 2. Well, that's this guy right here, 2, 2. So I'm going to send this to the swap function so that it can swap this particular button. I'm also going to swap the one above it. But how do I define the button above the one that I clicked? Well, notice this. The button that is just above it, right, the row increases from 2 to 3, right, from 2 to 3. So what I'll do is I'll define north as taking the row plus 1. Well, what is the row? It's 2. Plus 1, that would be 3. So row plus 1 refers to this row. The column is 2. Here it is. So 3, 2 intersection, that's this button right here. So now, as you can see here, using index arithmetic, I think that's what it's called. Yeah, index arithmetic. I can now refer to the row above, or the north row. I can also refer to the south row. I just simply subtract 1 from the row, and that gives me the button below the one that was selected. How about the one to the right, or the east button? Well, then I just simply take the column plus 1. See, the button that was clicked is on column 2. The one to the east of it is on column 3. So I simply say column plus 1. Notice the row is intact, right? Because the button to the east is still on row 2. And so this is referring to the button to the right, or the east button. And then I can do the same thing with the west button with column minus 1, since I want to go over here to the previous row, or to the west. And notice how the 2, when it's decremented, is 1. So that's 2, 1. This is the button we are referring to. So that's why I wanted to know the row and the column, because by knowing the row and the column of the button that was clicked, I now have a way of referring to the one to the north, south, east, and west. And I use that index arithmetic to swap those appropriate buttons. So now those colors are swapped, as you can see. Let me go back over here. That's what they were when they call the swap function. When I call the swap function, now they're swapped. Okay, again, the reason why I wanted to have 5 functions like these, or 5 calls to swap, is I wanted to make it so that any button that is clicked, it changes the one to the north, south, east, and west, in addition to the one that was selected. Now that I have these perimeter buttons, I can do the same code. Let's say that the user clicks this bottom left button of the game. Well, that's located at 1, 1. Having already explained that we want to change the one to the north, south, east, and west, now I have a way arithmetically or mathematically of referring to the north, south, east, and west. So I don't care what these buttons, what their color is. Who cares? I mean, they're phantom buttons. They're in memory, and I'm not going to see them anyway. But I certainly want these two to change. So when this code executes, now you can see what happens. They swap in color. Okay, so that's the little PowerPoint presentation that I wanted to show you that I think will give you a better understanding of what's going to be happening in our game. So here's our particular game setup. Let me just show you some of the things that I've done here to give you a clue in terms of the design of the graphical user interface. So I made these 75 by 75, and I had to move them right next to each other, as you can see here. The name of this button is LBL11, or not LBL rather, BTN. BTN11, BTN12, 13, and then going up BTN21, 2223, BTN31, 3233. I call this BTN reset. I call this LBL moves. So again, similar to what we did previously. Now let's take a look at the code. Okay, so what I want to do is when I first load the program, okay, so on form load, that's what I need to randomize my buttons, and that's also when I need to instantiate the array with elements. So I declare row and column. I place those 9 buttons that we created in the design view, that's BTN11 through BTN33, I place them into the array game buttons 11 that, as you can see, was declared up here. So game buttons 11, actually, you know what I should have done is I should have put a -1 here and a -1 here, because this is really it's not really the row size. What it really is the last index of that array. And if I said 5, that would be 5 minus 1, which is 4. So from 0 to 4, let me hold up my hand here. So 0, 1, 2, 3, 4. That's a total of 5. And the same thing over here. So I want to create a 5 by 5. All right. So now I have a 5 by 5 array. And starting at 1, 1 of the array, I'm going to place BTN11, just like that PowerPoint presentation that I shared with you. Let me go back over here and see if I can fix that slide. Here we go. All right, so at 1, 1, I'm going to place this button. At 1, 2, I'm going to place this button, so forth and so on. So that takes care of placing the buttons that we've designed into the array. Now, what are we going to do for the rest of these perimeter items? So let me scroll down here a little bit. We're going to place phantom buttons in there. We're going to place. Now, the reason why I call them phantom buttons, they're buttons still. It's just that they're buttons that you and I don't see. They're buttons only in memory and not visibly on the screen. So that's the code that places buttons inside of these array elements. Now Look at this little tiny code right here. I can have a nested for loop instead of the outer for loop. And what I can do is I can say, for all these buttons, I want you to have a special handler. So whenever you are clicked, whenever the user clicks any one of you guys, which actually would be these buttons up here since these are visible on the screen and these are not. So whenever the user clicks on one of these, what I'm going to do is have you jump to the btn array click function or handler. Now, what a handler does is whenever a user clicks a button, let's see if I can go to the reset button over here. All right, here's the reset button. So when the user clicks the reset button, it goes to this particular handler, and this handler is called btn reset click. So when the user clicks this button, go to here, and this is how we're going to handle when this is clicked. And if I were to double click this button, which I'll do now, notice how it generates a handler for me, right? So btn3_1 click. When I click that button, this is the button, this is the code that's going to handle that click. I don't want to do that. I don't want to go to a separate handler. What I would rather do is I would rather go to a predefined handler that handles all of these buttons. And what did I call that? btn array click. So I want all of these buttons, if they are clicked, to go to here. Well, how do I do that? Well, in this case, let me go back to that statement. I use this statement right here. If you want a button or a series of buttons to go to a specific handler, then you just say add handler, and then whatever the name of the button is. Well, in this case, it's an array of buttons. So that's why I call it game buttons row, comma, column. And then dot click, right? It's the dot click property of that button that I'm interested in jumping to a specific handler. Now, where is that handler located? Well, the address of that is me dot, and then btn array click is the name of the actual handler. So I do this for every single button. Now I have a way of jumping to a given handler. And then I call game setup to randomize the puzzle. We've done this before. You can take a look at the code for this particular program to understand that. All right, now let's go over here to this btn array click and understand this part of the program. Well, that's over here. Well, what I'm going to do is I'm going to declare a temp string variable as a string. Also, for row and column, I have them as integers. Declare those as integers. Remember, I told you that all handlers have a sender item or a sender object. Now, what this sender object is the identification of the thing that is being sent to this btn array click sub. So if btn1_1 was clicked, then this thing is btn1_1. So any button that is sent, this sender object has the name. So sender.name is just the name of the button that was clicked. Let's pretend that the user clicked this button right here, btn11. When btn11 is clicked, the sender name is now literally the string btn11. I'm going to place that into a temporary string that I just declared over here. Now that I have that temporary string, I can use substring to extract this 1. How do I get that 1? Well, that's 0, 1, 2, 3. That's in the 3 position. See the 3 right here? I only want 1 in length, 1 character in length after I get to the 3rd position. See that 1 right there? So, in essence, what this thing does is it sets row equal to that integer. Now, really what's happening here is this. Okay, so this is a string. I shouldn't be putting a string into an integer. What I should have done is set convert dot to int32 parentheses and place that whole thing. Place this whole argument into this because this is a string, and then I want to convert it to an integer that I want to place into an integer. So I don't want to let Visual Basic do it for me implicitly. I should be doing it explicitly. Same thing for this statement down here. We need to get this number, which is the column, right? This represents the row, this represents the column location of this button. Well, where is this located? 0, 1, 2, 3, 4, 5. This is located at the 5 position. That's why I have substring 5, and I only want one character. That's why you see the 1. I only want 1 in length. But this right here is a string, and I need to convert that into a number to place that into a number. So I'm going to type convert .toInt 32 parentheses, and then I'll put a parens at the end. There we go. So now I have the row and the column value of the button that was sent. That's why I strategically named it this way, so that I would know it's row and column. Well, now that I know it's row and column, I now have a way of determining what button is to the north, what button is to the south, what button is to the east, and what button is to the west. If I now know how to distinguish and to identify the button to the north, south, east, and west, in addition to the button that was actually clicked, I can now call the swap function to actually swap the color of the button that was selected. Oops, let me go back over here. The button that was selected will be swapped. The button that is to the north, the button that is to the south, the button that is to the east, and the button that is to the west, they will all get swapped. It may very well be that if the user clicks this one right here, only the north and the east are swapped, and the one to the west and south, well, they get swapped just in memory. Who cares, right? We don't see those anyway, but they also get swapped. Well, I increase the moves. I display that to the moves counter so we can keep track how long is it taking till the user is able to solve the puzzle, and then we check to see if the user has won the game. Namely, are all the colors the same or not? And I'll let you look at the code for the remainder of the program here. It's very similar to what we had before in the previous game that we created, but this time we're using a two-dimensional array. Alright, so that's it. I think now that you have a basic understanding of using the two-dimensional array, this is a much more elegant way of solving the problem. Notice this, it's just this right here. As opposed to code, 9 chunks of code, 9 different subs for handling all of these individual buttons. Now we have a way of just calling one function, or one sub in this case, that will automatically swap the colors for those 9 buttons. And that's it. Okay, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. We'll see you next time.